Alright guys, now we're moving into 9.3 on rotations. Up to this point, if you remember what we did in 1.7, we introduced all our transformations, our translations, our reflections, and our rotations. So kind of going through chapter 9, this is the third of those three transformations that were previewed in 1.7. So you've seen this before, is what I'm trying to say. It's a quick warm up here. Again, if you know how to do 1 and 2, go ahead and do it real quick and just kind of check your answers because it is a review at this point. If you need some additional help, then kind of watch this part of the video and kind of work it out as I work it out. But like I said, if you already know how to do it, just check your answers. Okay, so here we go. Number 1, we got a translation of P to P prime. So what they're doing in this example is they're showing you how much your graph is being translated, or your point, so you can use that to find Q prime. So what we're going to do over here, we're going to come over here, number 1, and we're going to figure out how far P has moved to get to P prime. So we have P is at, what's it, -3, -1. And then we want to figure out how far has it moved to get to P prime, which is 1, 3. So I'm going to look at each part. First part, we're going from -3 to 1, so that's going to go right 4. And then we have our -1 to 3 is the same basic premise. You're going up 4 in this case. So that's giving you your translation rule. So if I'm going to go from Q to Q prime, well, Q is at 2, -4. So in order to get to Q prime, we're going to go, and I'll write Q prime while I'm at it. Q prime is going to be 2 plus 4 and -4 plus 4. Therefore, Q prime is 6, 0. Again, we use the translation rule that we learned finding our preimage of P to our image of P prime. Alright, so that's going to be number 1. Number 2, do that right there. Says we have a rook on a chessboard. It has coordinates 3, 4, and it is moved up 2 spaces. Then it is moved 3 spaces to the left, and what is the rook's final position? So you can picture this or just do it algebraically, just to give you an idea what it would look like on the coordinate plane. 1, 2, 3, 1, 2, 3, 4. So we're going to move this up 2 spaces, so which means I'm going to need a little bit more space up here to show it. So that's 4, 5, 6. Alright, so my first point is going to be here at 3, 4. So it's 3, 4, and it's going to move up 2 spaces and then 3 to the left. So if you're going to try to draw that, I'll do blue. You're going to go up 2, and then you're going to go move 3 spaces to the left. So I'm at 3 right now, so it'll put me right there at 0, 6. So if you look at it visually, you just plot, you just move it and plot the points, and you can get your points. But again, you had to go up. What was that? One more time, because I'm going to need that in a second. Move up 2 spaces, so up 2, and again we went left 3. I'll just LT there. Okay, so first off, you have your point. We can call that point, I don't know, point P. Well, that's point P. That other point, 0, 6, we call P prime. So if I was going to write it down here, I would have P was 3, 4, and P prime was going to be 3, and we went left 3, so 3 minus 3. And 4 went up 2, so it'd be 4 plus 2. So this is how you would do it algebraically. So P prime would be, again, 0, 6. So if you did it algebraically, that's the way I'd probably do it. I just want to show you the visual. The second part of this question says, what single vector moves the rook from its starting position to its final? So I'm going to use we call that component vector format, and what it does is it gives you your horizontal and your vertical movement. So again, we don't use parentheses when we do a vector. Also, it's half an arrow here, not a full arrow. A full arrow would be a ray, and when this is an array, it's a vector. So vector doesn't go forever. It does have an arrow, but it doesn't go forever. So anyway, this one is going left, as we said, left 3 and up 2. So you would write it as -3, 2. And if I try to draw it, it would look like that. Again, it would end at 0, 6. Okay, so those would be your answers here. We have your vector, I just called a vector P to give it a name, and we had P prime, which was our point after the transformation. So that's our warm-up on our translations. Again, we're going to move into in 9.3 rotations. All right, so what we're going to try to learn today is, just like what we did in 9.1, 9.2, you're going to need to be able to identify and draw. In this case, we're identifying and drawing rotation. So you can kind of see it's very similar to what we did in 9.1 and 9.2. It's just kind of building on itself through your different types of transformations. So again, that'll be our goal as we go through this lesson. So we'll just have to see how this one's a little bit different. Okay, again, quick reminder of what a rotation is. It is another isometry, which means that once we move the figure through our rotation, it's going to be congruent to the pre-image. So again, a rotation is an isometry, so the image of the rotated figure is congruent to the pre-image. Alright, so this is just yet another isometry through our transformations. Alright, so example 1, we want to be able to identify rotation. Now, to identify rotation, we need to see some sort of turn. So in this case, it doesn't really tell you where you're starting from. So I'm going to start, in this case, from the blue image and go to the red image. Now, this one, what you want to do on all of these actually is you want to pick a point. But with rotations, it's more than just that. You can say, oh yeah, I rotated, yay. But what you would have to realize that when you rotate, the orientation of the figure itself, the whole thing, would have to turn. So if I rotated this 90 degrees about a point, you're going to have to be able to see what that point is, which we'll talk about in just a second. But your image would look something like this. It would be much prettier than that. But you'd be able to see that the image itself is turned. And well, in this example, that's not happening. This is actually a transformation. If you look at this point, you're going right a specific distance, and you're going down a specific distance. You could draw a vector to represent that and get your transformation. So this one would be a nope, a no. You can say nope. I'm going to say nope. This would be nope. Does it appear to be a rotation? Nope. This is a transformation. Or translation, sorry. Yes, of course it's transformation. I always get those mixed up. It's a translation. So A is a translation, not a rotation, because the orientation never changed. However, if you look at this one for B, we have this point right here. It looks like it's rotating about that point because you see how that point doesn't change. But if I take any specific point here, I'll use this one and this one, you can kind of see, so I look at this, I'm going to try to draw it. It's hard to show here, but you can kind of see, use these two sides as an angle. It's hard to see on there. Hopefully you're seeing my little dotted line. Looks like it's rotated 90 degrees. It doesn't have to be 90, but it's close to it, so I won't call it 90. But you can see how the orientation changes as it rotates. So if we use this point here as our center of rotation, you can see how it's rotating in a counterclockwise direction to get you to that second point. You see the orientations change. And that angle would be the same for any given point. So here I got this angle right here. It's going to get ugly right here, I'm going to tell you now. But that angle would be congruent to that angle. Any angle you draw from any point would actually be congruent. So again, just so you kind of see that, this would be a rotation because you can see the graph, or the figure itself has kind of changed orientation, and it looks like it's going rotating about a point. So this would be a yep. This is a rotation. So again, don't just look to see if it's moved, see if the orientation's moved. Now if it's completely flipped, like if you go from this to this, remember that's not a rotation necessarily. That could be a reflection. But again, the way it's described, you could rotate this because it's symmetric. If you flip this around 180 degrees, it could work. It depends on the scenario, but you need to make sure you can determine. I mean, obviously, I'm not going to give you a situation where it could be either or. That would be kind of a trick question. But make sure you understand, are we dealing with a reflection or rotation? Like, obviously, this one is not a reflection. So make sure you understand that even though we don't see one here, you could still have reflections. So be ready for those. Okay? So again, homework-wise, you can probably do 12 through 15 now at this point. They're the same types of problems. Alright, so again, a couple of things I was talking about as I was going through identifying those rotations is this concept of a center of rotation. So that's what we're going to have to be able to do. Now there are a couple of things that will pop up in here because we jump to chapter 9 that we will kind of skip over. You know, you may see things written in the book about your trig functions. Well, we're not going to be dealing with the trig functions at this point because we haven't learned about the trig functions, obviously, so don't freak out about that too much. Just kind of focus on what we're going over in the lesson. We're just going to go over the basics here of rotations. So in this case, it looks like another 90-degree rotation here, but the key is when you go from your pre-image to your image on any given vertice, you should be able to construct two congruent line segments about a center of rotation, and that angle will tell you how much you rotated. So you'll see that again, it can get kind of ugly when you draw it because you're going to have overlapping angles. So that's something you're going to have to deal with, but understand the basic premise, which I'll show you as we try to show some of these rotations here in a little bit. Okay, but again, I'm going to mention center of rotation on a lot of these. You have to find that center of rotation so you can set up your angle. Alright, the next thing that you want to see, and you'll see it as I went over it in the previous example, unless it's stated otherwise, we're going in that counterclockwise direction. So that means if I have a point here, if I say I'm rotating it 90 degrees, you know, we're going to rotate it that way. And again, if this is our center of rotation, you know, that should be basically our P and our P prime, something like that. Okay, but it's going to go in that direction. Unless otherwise stated. Now if I say you're going to go 90 degrees in a clockwise direction, then obviously we would go in a clockwise direction. Okay, that's just the given. That's true with not just this book, you know, it says this book. That's true with angles in general. When you get into trigonometry and things like that, any positive angle is going to go in a clockwise direction, and if you go in a counterclockwise direction, if you end up going in a clockwise direction, you would have what's called a negative angle. We are not there yet, don't worry. But again, this is more of a given truth, or a given statement, not a given truth, not postulate. It's a given that you're going counterclockwise unless otherwise stated. Okay. When we start doing our rotations, again, we're going to do it in the coordinate plane. We got to be able to calculate the angles, or at least, you know, if given an angle, can we copy it and use it in our rotation? You are going to have to know a couple rules. So know these. These are not postulates or theorems. Make sure you're aware of that. What these are, they're just concepts and things that you need to know, mathematical concepts. So this one, I'll start with the origin one. This one's kind of easy because what you're doing is you're actually doing translations, or not reflections. And what you're doing is you're reflecting. If I'm going from P to P prime, you're reflecting over the x-axis. And if you remember the rule, if you reflect over the x-axis, your y value switches signs. Okay, and then, so that's why you get a y to negative y, and then you're going to reflect over the x-axis. So it's the same as a reflection. I kind of mentioned that a little bit earlier. If you reflect something 180 degrees, it can be considered a rotation. Again, it will always depend on the scenario, but as you can see here, 180 degree rotation, you can see how that point becomes xy to negative xy. That's the same as doing two reflections at a time. Okay, so this rule should make sense because you've probably used it. We've used both of the rules individually, and this is combining them. So reflecting something over the x and the y-axis is the same as rotating an image 180 degrees. So again, you want to know that rule, and these are rules you gotta know. I mean, just, you know, these concepts, obviously these are things you need to put in your memory bank. And then we have a 90-degree rotation. And this one's a little tricky. I mean, you got to be able to follow along here, but if you just look at these points, what you'll see, and I'll kind of use this as a guide, it looks like I'm going right a lot, up a little, but once I rotate at 90 degrees, look, I'm going left a little, up a lot. So again, understand what that means. Here, it looks like I went right a lot, so that would be right x, and up a little is y. Now that can always change around. You could have a point up here. The rule won't change. Okay, you're going right a lot, up a little. Now I rotate 90 degrees. Now it looks like I'm going left a little, so that would be negative y. See, y was your little. Okay, think of just y as not a y value. Think of it as a distance, and that distance is a little. Okay, we don't know what it is, but it's a little. So now I'm going left a little. So now we have negative y. And I'm going up a lot. So remember, we call a lot x. So that kind of takes care of that as well. So now I have my point for p prime, my image, negative y comma x. So going left y, up x. To make this a little simpler, I can use another example. I'll do it off to the side of rotating 90 degrees. It doesn't have to be in the first quadrant. So let's say I had this point. I'll call it p prime, and not make it as confusing. Let's just call it negative a comma b. So it's not x and y. And I'm going to rotate this 90 degrees. So I'm going to kind of come down here, come over here, and I'm going to get this point. Now if you look, as I first label this, it looks like I'm going to go left a little and up a lot. So that would be negative a comma b. But when I do my second point, looks like I'm going a little bit overlap. Again, you're going to see a lot of this, but I'm going left a lot and down a little. So that'd be negative b, because that's my lot, down a little, so negative a. Therefore, sorry, I called that p prime earlier. Let's call that p. Get ahead of myself. I feel I'm going to erase all that. No, I didn't. Okay, good. So that way, when I get to p prime, you kind of see what I did. I went left a lot now. Remember, that was my bigger value was b. So think the later number in the alphabet was bigger in this case. Okay, so I'm going left a lot, so it's negative b, and then down a little, which is negative a. So again, what you're seeing here is the same rule. You go xy, negative yx. The x value, in this case, was negative a. See how it didn't change? Okay, even if it's negative, it doesn't change. The y value flips. But again, if you visualize it, you can kind of see that concept as well, which obviously helps out, you know, when you're trying to understand things. If you can also visualize it as opposed to just, you know, rote memory, it kind of makes more sense. So I'll kind of connect these two, so you have a couple examples of why that works. Again, it's easier to understand something than to memorize it. So that's why I do those extra examples for you. So again, at this point, we're not really going to worry much about sine or cosine. Not that they don't exist, but we're going to learn those later this year, so don't worry about those yet. But these are the concepts here. All right. So now we're going to go ahead and try one of these. So it looks like we got a triangle ABC. I'm going to have to draw this. So we're going to draw a XY plane. Again, if you have graph paper, that obviously helps, because I can't draw very good on here anyway. Okay, so I'm going to go out. Looks like 4 is my maximum value. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Don't mind my ugly y-axis. Okay, so again, this is going to get a little messy. As I said, we got 3 of these that we're doing. So I'm going to do my best here. The less I write, the nicer it'll look. I like to show things. Hopefully I won't have to draw. I'll try not to draw all 3. But I'm going to start with A. I'm going to try to at least color code this a little bit. So A is 2, -1. So 2, -1. It's going to be right here. So A is 2, -1. Now before I draw the entire triangle, what I'm going to do is I'm just going to rotate each point 90 degrees, and then I'll connect them to draw my triangle. So if I'm rotating 90 degrees, it's a given that it's going to be a 90-degree angle, but it's going in a counterclockwise direction. So again, what you look at here is I'm going, and I'm going to do it off to the side. I think that'll be easier. So I'm going right 2, down 1. Again, until you memorize the rule, you want to understand it. Because if you just try to understand it first, this way, if you forget the rule, you'll still be able to use it. It won't matter. So in this case, you got to understand I'm going about 90 degrees. So you're going to have this angle here. It's going to go up 90, the same distance. Okay. So what you have to do is realize I'm going right a lot, down a little. Well, here I'm going to go right a little, up a lot. So you got to make sure you can follow that. So A prime, you're going to go, again, right a little. So in this case that was -1, now it's a +1, and up a lot. So that used to be this value, right? So that'd be 2. And again, you can follow the rule and understand what happens. You go from xy to -yx. Okay, you know the rule, great, but it's easier to kind of being able to visualize it, so you can make the rule up in your head. You don't have to memorize the rule. You can just figure it out. So I'm going to go to 1, 2, and I'll label that point right here. So I have A prime right there. I have my work off to the side, so we're good. Then B, I have 4, 1. So I have 4, 1, 2, 3, 4, 1. So here's B at 4, 1. Same thing off to the side. So 1, 2, 3, 4, 1. And I'll go ahead and move this up. Okay, so I'm at 4, 1. And I'm going to move this, same thing, I'm going to move this 90 degrees. If you kind of know the rule, you kind of know where to put it. But again, I was going right a lot and up a little. Think of that as your distance. So now it looks like I'm going left a little, and I'm going, and if you look at this distance here, you got my point off a little bit. But this one is going to go up a lot. So again, remember that this was 4, 1. So if I'm going left a little, it's now -1. Up a lot is +4. So this is going to be at my B prime. So -1 B prime, I have -1, 4. Again, you memorize the rule, you'll know that by rote memory, but the thing is you forget things, and that's okay if you understand the rule. So now we got our second point. And I got one more here. I have C, which is at 3, 3. So 1, 2, 3, 1, 2, 3. So we have C at 3, 3. Now this one, it's a unique one a little bit. It's kind of nice actually. These are some of the nicer ones when the points are the same. They're easy to draw. If you don't know what I mean, you'll see in a second. 1, 2, 3. 1, 2, 3, and 1, 2, 3. The thing is with the rule, the values don't change. The signs do. The points will flip around. One of the signs changes. The Y does. But again, that's what makes it nice here. Is like I know I'm going to be at, I'm going to have 3 and 3 for my points after I do my rotation, because the values, the numbers don't change. They just get flipped around, right? So if I'm at 3, 3. and I'm rotating 90 degrees, it's easier to draw this one. I know I'm going to be over here, kind of where the 3 and the 3 connect. So you can just kind of plot that. That's -3, 3. It makes it actually a little bit easier, because you can't go right a lot and up a lot. It's basically right a medium amount, right, and up a medium amount. So it's the same distance, right? So if you go left a medium amount, that's -3. You go up, that's off a little bit, just kind of make pretend. But you go up a medium amount, that's positive 3. You just got to get the signs right. So this is at negative 3, positive 3. So negative 3, positive 3. Okay. Oh, there we go. And now we have C prime at negative 3, 3. So again, we can go ahead and connect this now. If I had A prime, B prime, and C prime, there is my triangle. And this was your original ABC. And you can see the rotation. It went that way. Okay. So that's how you do a rotation algebraically. This would be your final answer in that case. That's something that if you really, honestly, if you don't practice this, you're gonna not know it at all, and you're gonna get it wrong when we test you on it, because we are gonna test you on this. So please practice. It's not like everything's just gonna pop into your head immediately. You got to work at it. The people that work at it are gonna get it. The people that don't are not, honestly. But again, if you practice this, if you learn to do it this way, visually first, the rules just kind of fall into place. You'll learn it over time, but it's more important to be able to work it out. Okay, so that's how we draw them, a 90-degree rotation, which is the harder of the two, right? Now again, the 180 degrees, I'm not going to do a whole thing, but you want to remember that rule. Okay, this one's a little easier to learn. When you go do a rotation of 180 degrees, it's the same as flipping over a reflection over the x and the y axis. So remember what that does is that flips the x and it flips the y. That one you should be able to remember pretty easy. You could write that one out, but that one's a pretty easy one to remember because you just flip both signs. It's not like the rotations where you like switch them and then flip the y. It can be a little harder to get that one straight. This one should be a lot easier. Okay. So again, if I had a triangle, it doesn't matter. I'm not giving you specific points here. I just want to kind of show you can apply that rule and graph it rather quickly. Now, if you need help graphing them, again, we have 18 through 21. We'll go over in class. No big deal. Okay. But I want to show you that 90-degree rotation. All right, so we are going to have a lesson quiz on this. Again, as you kind of look, we have one workbook one I'm going to do with you. We got our assignment. But again, we are going to have a quiz on this. Sorry, I'll leave it up so you can pause it, take a look at it. So just remember, make sure you bring in your notes and your lesson quiz to class. And this one's just 3 questions. Okay, so as you can see, it's basically talking about what we did today, being able to identify the transformation, and then being able to translate or do a translation of 90 degrees of rotation of 90 degrees and 180. Okay, so that's something you want to bring in with you to class. Now, just to give you one tricky one here, there is this workbook problem, and this one is one that might be a little tricky for you, so I want to kind of go through this so you can see something that's not 90 degrees. However, it has that relationship of a 90-degree rotation. So if you understand this visually, you will be able to attack this one rather easy once you understand the concepts. So this one, again, I challenge you to try this first before you just go ahead and watch me do it. Okay, so first one, let's start with the easy one here. First, what you want to know and understand is 270 degrees. What this is, if you divide by 3, and I'll show you the work here, it's 90, but you go 270, 3 goes into 27 9 times, and then we'll pull down 27, 0. We're doing a factor here of 0, so this is 3 goes into 0 times, and you're going to end up with 90. So anyway, 270 degrees is equal to 3 times 90, which means it's 3 90-degree rotations. So you can look at it one of 2 ways. I can go around 270 degrees, or I can go clockwise 90 degrees, which is going to be a lot easier. So again, the only other interval in between there would be 180, which is another one of our rotation rules anyway. So all I'm going to do now is I'm going to take this and I'm going to go 90 degrees. Now I'm going to start at the easy point because this one is easy. I'm going to use the center of rotation as 0, 0. So you can kind of see your right angle right here. Remember, I'm going clockwise now. And you can kind of see that if I'm going to start at 0, 3, I would end at 3, 0. So that one's actually not so bad. Actually, I'm sorry, that's 0, 2. You can see the point down here. So this point would be at 2, 0. Okay, so again, we'll do this one at a time because I'm probably going to want to erase this because it's going to get really messy. So you can kind of see that as my first point going 90 degrees. You got your two congruent segments coming from the center of rotation to your vertex for your pre-image and your image. Okay, but I'm going to erase that so you can see the other ones without it looking really confusing. All right, next up we're going to look down here. So remember how I have you remember this, especially since we're going clockwise now. You want to see if you can trust yourself. Here I was going right a little, up a lot, right? So I'll also use L and U this time. I'm trying to do something different to kind of keep it something so you can understand. Oops, I don't know why I said 4. Oh, it is 4. I didn't even think about that, but I said 4. This is right a little, up a lot. So I guess I can't do little and a lot. So because they're both L's. Sorry, I'm trying to do different things with you guys to help you out. We'll just put the numbers in here, okay? I think that's fine at this point. So I have this triangle, and I'm rotating that triangle 90 degrees in a ways, but this is the line I'm looking at. So this line, I know I'm going to have a 1 and a 4 here. I just need to figure out like what direction is it going to go. Well, if I go 90 degrees, it looks like I should be at 4, -1. You can see how that angle right here is 90 degrees. That's supposed to be a little right angle sign. So it looks like here I'm going to go right 4 and down 1. So this point would be at 4, -1. Again, picture it. If you picture it, it's not so bad, and you don't need to second guess yourself. So this is where graph paper, again, is really handy. So this would be 4, -1. Notice in this case the y value, or sorry, the x value became the y value. It switched. That's the opposite of what we were doing. Alright, so I apologize. Looks like there's a little skip in my audio, so I had to go through this last point one more time. But what we're doing is we're taking the 0.42. As you can see, like I said, they gave us 3, 1 already. But we have the 0.42, which is, let's see, 1, 2, 3, 4, 1, 2, this point right here. And we are going to rotate that 190 degrees. And again, I know at this point, as I'm getting to this point, I'm going right 4 and I'm going up 2. So when you rotate it 90 degrees, you can, again, you're going 90 degrees clockwise. You know that you have to use the points 4 and 2. And if you go 9 degrees, it looks like I should be going right 2, down 4. And again, you can double check that when you draw your two congruent segments and see if they form that right angle, which they do. So this would be 2, -4. So therefore your point would be 2, -4. So again, as you look at all three of these, you can see that they try to, they're trying to help you really, but I never mentioned it until now because we didn't need it. And they're telling you about that, the rule. They're trying to say, hey guys, look, we kind of gave you the first point so that you can figure out this rule that you can memorize and you'll forget in like a day. Because that's really what's going to happen if you try to memorize it. Visualize it. Draw it. If you can draw it, then you can get the points. You need to understand some basic concepts, but you don't have to understand everything if you know how to draw it. And the nice part is, when you draw it enough, you'll learn the rules anyway. It'll just kind of come. And if you do happen to forget them, you can still draw it on a quiz, draw it on a test. You don't need to memorize the rules. Okay, but the rule in this case, if you're going clockwise 90 degrees, is that the x value is the one that switches signs. The y value just switches sides. Remember, you always go from xy to yx, but when you did your counterclockwise, the y switched. But you're going clockwise, the x switches signs. So again, you can memorize that rule, but you're not going to remember it. If you can draw it, you'll remember it. Okay, so in this case, we have a rotation of 90 degrees. So that's really all our main angles, your 90 and your 180. The 270 was another 90, just clockwise. So those are your basic rotations. There are others. We talked about sine, cosine. We'll learn about those later. We're not doing that yet. Alright, so at this point we're basically done. We have at this point the assignment. Now if you have this more She'll tell you what you should be doing. If you have me, I'll tell you what you should be doing. I'm leaving this up in case, like I said, we assign this, but again, we'll tell you what's assigned. Okay, and then next up, again, we have your rate yourself. How do you feel you did in this lesson? I'm not, and we're not at this point in the classroom getting a feel for where you're at. So that's why we require that you do this. We need to get a reflection from you so that we can see how you understand the lesson. So again, scan the proper QR code. If you're with Miss Moore, scan hers. If you're with me, scan mine. Fill out the reflection form. Again, that's the only way we know how you feel about this particular lesson. That's true for all the lessons. So make sure you fill that out, and I will leave us with the lesson quiz page. I think it's here. Yes. Make sure when you come into class you got your notes done and you got your lesson quiz done. So if we ask for that, you will have it. Okay, it's only 3 questions. It's exactly what we were doing in class or in our notes. So make sure you get those right. If you can obviously ask anyone, you can look anything up, you can work with people, it's okay. I want you to get it right. I want you to understand it. So bring that with you to class, and obviously we're going to work through our lesson in class. And with that, good luck, and I'll see you guys in class.